lifetime and reliability, which is a favorable feature for the R290 to be used in the high ambient temperature region. So compared to the R22, R290 have lower cooling capacity, but it has a higher COP. When we're talking about development of a new refrigerator compressor, following aspects must be taken into account: performance improvement, motor optimization, displacement determination, lubricant development, reliability, material compatibility, mechanical structure optimization, and for R290, another important issue is safety issue. So first of all, we'll talk about the oil development. So as we know, the oil used for R22 have a good miscibility with R290. This would lead to the oil viscosity to be very lower in the compressor, which will influence the compressor reliability. So for the R290 compressor development, we should develop a lubricant which have a proper miscibility with the R290. Since too bad miscibility, it could increase the viscosity, but it could cause the oil retention in the heat exchanger, which will influence the heat exchange efficiency and compressor reliability. So during the oil development, we use a viscosity sensor installed at the bottom of the compressor to test the oil viscosity to make sure we have a proper viscosity to make sure the compressor reliability. So another important is compatibility. So the oil and the refrigerant should have good compatibility with the material. Otherwise, it will cause many problems, such as rapidly reduce the motor life and block the capillary or expansion valve. So the material includes the materials in compressor and the materials during manufacturing of the compressor. So we carried out different experiments to verify the compatibility. In the compressor, oil plays another important role. It's sealing the liquids clearance between the movement parts. Here is a rotary compressor. It mainly has 4 liquid passes. For the sealing effects, the oil viscosity and solubility play a very important role. Here we used 3 different oil to test the performance of the compressor. We can see the oil can greatly affect the performance of the compressor. So when we develop oil, we need to combine the above mentioned factors. So it's a balance between these factors. The second part, displacement determination. So when we replace a R22 compressor with a R290 compressor, we need to determine the displacement. Here we test 2 compressors. One is R22 compressor, another one is R290 compressor. They have the same displacement. We can see, compared to the R22 compressor, R290 compressor has about 12% lower cooling capacity than the R22 compressor. So for the same cooling capacity air conditioner, the displacement of R290 compressor should be about 12% larger than that of the R22 compressor. As above mentioned, we know the R290 compressor have lower suction pressure and discharge pressure. It leads to a lower pressure difference and lower pressure ratio. So we need to optimize the mechanical structure according to these factors. So here we use the CAE and CFD to simulation to make the optimization. So usually the R290 compressor is developed based on the R22 compressor. As above mentioned, the R290 compressor have lower power consumption compared to the R22 compressor at the same displacement. This figure shows the motor efficiency variation with power consumption. We can see the motor efficiency reach maximum at a specific power consumption point. So we need to optimize the R22 compressor motor according to the R290 compressor power consumption. So make sure the R290 compressor motor efficiency reach maximum at the R290 compressor power consumption point. So for R290 compressor, another important issue is the safety issue. So many international standards have set the charge limit for the flammable refrigerant for the safety reason. So for the R290 compressor, an important method to ensure the safety is reduce the charge amount in the compressor. Mainly we have this method. First of all, we can reduce the cell internal volume to reduce the charge amount in compressor. For example, we reduce the cell diameter from 112 millimeter to 107 millimeter. The volume reduced is 60 milliliter. Since the density in the R290 in the compressor cell is gas state, so the density is lower. The reduced R290 is only 2 grams. So by the same way, we can reduce the cumulator internal volume here. The diameter reduced from 70 millimeter to 65 millimeter. The volume reduced is 66 milliliter. Since the R290 in the accumulator, the density is very lower, so reduced R290 is only 0.7 grams. We know in the compressor, part of R290 will dissolve in the oil. So the solubility will have an influence on the R290 charge amount. Here we have two kinds of oil. One is POE, another one is mineral oil. The solubility difference is 5%. So for 1 horsepower air conditioner, which the typically R290 charge amount is about 300 grams. So by using the POE oil, we can reduce R290 charge amount by 13 grams. So it's a big amount.
1 minute.
Okay. So we can know the oil play a very important role on lowering the R290 charge amount. So we can optimize the oil supply system to lower the oil level, then reduce the oil charge amount. So take 1 horsepower air conditioner example. If the oil charge amount could be reduced by 50 milliliter for the POE oil, R290 can be reduced by 90.5 grams. For mineral oil, R290 could be reduced by 7.5 grams. So here I make a brief conclusion. To lower the R290 charge amount in compressor, the focus should be kept on lowering R290 solubility in oil and lowering the oil charge amount. So another one, we know the R290 is flammable, R22 is not flammable, but this is in the atmosphere. So with the pressure increase, so what will happen? Here we perform a research on this. The x-axis is the R22 or R290 mass in the air. The y-axis is the pressure. We can see with the pressure increase, the R22 becomes flammable, and the flammable range will increase rapidly. So with the pressure increase, the R290 air mixture flammability limits maybe is narrower than that of the R22 air mixture. So finally is the conclusion. So R290 is receiving high attention as a possible candidate replacement for R222, especially for the high ambient temperature region. The key important points to develop R290 compressor include oil development, displacement determination, structure optimization, and motor optimization. To lower the R290 charge amount in compressor, the focus should be kept on lowering R290 solubility in oil and lowering the oil charge amount. So with the pressure increases, the R22 air mixture flammability limit is narrower than that of the R22 air mixture. So that's my presentation. Thank you for your attention.